Yay. Okay, I'll take it from here, Ken.
Go for it.
All right, thank you. Okay, so my name's Ron Pointer, and we're going to talk over drone platforms and hardware. So really kind of the fundamental question you got to ask before you're going to bring drones into your classroom is, ask yourself, why do you want to bring them in? Is it to explore new ways to teach coding? Is it to help students get through a certification to get a Part 107 remote pilot's license? Is it more to teach team building? Because these aircraft that you bring in as kits typically are built in teams of students. Is it just to introduce new technology? You just have to kind of figure out what you're trying to do. Is it more of a competition where you want the students to compete and kind of get excited about things? So having a pretty good feel for why do you want to bring them in is going to help in the decision to decide what you want to bring in. So what we try to stress as we talk to teachers and students about aircraft is that these are tools and not toys. As you start at elementary school, then they're kind of more fun to play with. But as you start talking about what drones can do, it's really important to teach that these are tools and not toys. These are just some visual examples. On the right, you've got an airplane drone that's doing mapping. The one in the center there is actually a drone that washes windows. That was developed by a group in Europe, and they actually originally built it to clean wind turbines. The one above it is for crop dusting. And then the others are doing visual inspections. So we stress that when a company or someone's going to use a drone, it is because it's to accomplish a task. So keeping that in mind as you talk through your students, but we stress that they're just tools and not toys, even when they're just racing. All right. So a couple of big categories really are indoor drones and outdoor drones. And then the other are the kits, are they ready to fly? So as you can kind of see, the two aircraft on the left there, they're both small, they're indoor drones. The bottom one is actually the Tello, and the one above it is a small indoor, it's kind of a Lego-ish drone. So the Tello is pre-manufactured, it's ready to fly. The Lego drone is one they have to assemble and put together. The two over above and to the right, the one on the far right is the Phantom 4 RTK, a pre-manufactured drone by DJI. The one in the center is a kit frame that students have to build and put together. They have similar capabilities, but that's kind of the idea is, do you want something that's fully put together, or do we want something that's a kit to build? So we're going to talk a little bit about indoor drones first. So what's nice, the ones that are pre-manufactured and ready to fly, these are all indoor ones, are all small. They're lightweight. They're generally inexpensive. A Tello EDU is about $140. The Lego type drones are in the neighborhood of maybe $50, $60. They generally will have propeller guards, though obviously not all of them do, but generally they do, and they're where it's very small. One of the disadvantages for these types of drones is they're not overly durable. You fly that Lego drone into a wall one time, it just comes apart. And you can put it back together, but you do that a few times and it's not going to hold up very well. The racing drones have propeller guards on them. They actually hold up pretty well. But once these drones are damaged, especially the pre-manufactured ones, they're not easily repaired or put back together again. So they do cost less, but their longevity in a classroom can be limited. Okay. Some of them are not as easy to fly as you think. The Tello is actually pretty stable. It has a look-down camera and acoustic sensors that help hold its position. Whereas the Lego drone, the racing drones, those aren't easy to fly. They're not overly intuitive, and they're not, like I said, not as stable as you'd think they are. So we talk about next big category is the outdoor drones. And so you have a couple different ways you can go with these. The pre-manufactured ones, that all of the outdoor drones tend to be very stable. For the most part, they all use GPS. Many of them have obstacle avoidance sensors. So you can put most of these drones into the air and they will hold their position there using the GPS satellite signals until the battery just runs out. And then they generally will just land themselves. So they got a lot of capability. They're more representative of what students will see in the industry. So if we're talking at the high school level and you're looking at students to get some experience with drones so that down the road they can get a job in the industry or go work for a company that's using drones and kind of be their drone expert, these are more representative of what they'll see out there. Even the ones that are kits, some of the more advanced drones, as you can tell, they may have to do some repair on their own. And so it's one of the advantages of the kits is they do get an understanding as they have to put those together of the components, the pieces and parts, and how they all kind of work together. They are bigger. They are typically significantly more expensive. They are more complex, and they require more safety awareness. When you've got a small drone, an indoor drone with a propeller that's about 1 inch to 2 inches across, not a whole lot of damage can those do if they clip somebody's fingers. Whereas these drones, the larger ones, those motors turn pretty fast. Some of them have carbon fiber propellers that are incredibly strong, and even ones that don't, they will do some damage if somebody gets their fingers in there. So you have to be more aware of the precautions and safety. If you're going to start using outdoor drones, you need to be more aware of procedures and things like that that you'll want to have in place as you use these. They're a little more heavy duty and require a little more planning and thought. I'll talk just a little bit about coding. I tend to have to issue disclaimers when I talk to teachers that I'm not an engineer and I'm not a coder, so no math questions. But coding is something that the telos, and there's some others that can do that. They're really good, innovative ways to teach coding. So a couple of screenshots here. It's example of block coding. So this is from Drone Blocks. Both of these are. But it's a block coding type interface. It works with telos, the telo EDUs. There's a CoDrone also has one that is uses coding. So they're good ways to kind of teach that, and you can see that they're just picking a block, sliding it over with an instruction, and it has the aircraft go through and perform whatever those features are. And so it's a good way to test, can they come up with the flight plan when they put it in there and they execute it? Did the drone do what they planned and wanted it to do, or did they make a mistake in the coding? And again, not a coder, but I know that's a lot of what they have to do in coding. They write the program, they test the program, and did it do what it was supposed to do? And if not, then they're going in and debugging it and changing it, figuring out what the problem was and fixing it. The telos have forward-looking cameras that they can use to recognize these QR code. I think they're called Rokus. I think Dennis Baldwin and Marissa Vickery, when they talk about coding in the next section, will have a little more detail than I have. But just give you an idea of that you can set those things up, program, so when the camera sees it, it performs a task or does something. So they're good in being able to do that. You can code in Scratch or a block coding, as well as Python and Swift. So it does get into some of that coding that a gentleman from Bell Flight was talking about, and their need for students to understand Python coding. So it's a good and innovative way to introduce a new way to explain and conduct coding classes. So indoor drones they're good in that you can they get some basic understanding of remote control. A fair amount of these are just controlling the drone, getting it to fly through a hoop or fly somewhere. It is a way to introduce first-person view. So you see the young man in the center there's got a set of the FPV goggles on. And the way those work, for those who don't know, is essentially the drone has a camera with a video transmitter, and his goggles are picking up live feed from the camera. And so the idea is the student has to manipulate the controls to maneuver the aircraft, whether it's through loops or whatever it is, but he's controlling it that way. And so it's a very different type of flying. Some folks that's where they start flying and they're great at it. Folks who start in drone racing, they're extremely good at that. Whereas folks who are doing more flying based on operating an aircraft to get it, say, in position to inspect something, may not be using the first-person view systems. But it's a very different way to do it. But it's good in that students can get a general idea of remote control and interfaces. So it's good from that perspective to introduce that. Outdoor kits, it's where we have a little more experience. They're more hands-on. We've done camps over the years with students. The upper left picture is a Girl Scouts we did with a Girl Scout camp. And some of these girls, they had never held a screwdriver in their hand before. So it was very different for them to do. They had to work in teams. So it was a great hands-on kind of project for them. It also is a chance to explain the different components of hardware: motors, flight controllers, electronic speed controllers, all the different components that make it fly and make it work. So you can explain what they are and how they interact with each other. Again, team projects, they do require a little more hardware skills and software skills. With these flight controllers, they always have to connect them up to a laptop or to a computer and go through several steps of configuration. So it exposes them to both hardware pieces and software pieces. On the teacher's part, it does require a bit more of a in-depth understanding of the drones to be able to explain it all. But again, there's curriculum out there that really helps walk through all of that. And this provides immediate feedback to the students, because if they put it together and they don't have something connected right, most common problem is the aircraft will just flip right upside down the first time they try to take off. And that's immediate feedback that they did something wrong. Sometimes it might be that they have propellers on upside down and they fire it up and motors spin and it just tries to plant itself into the ground. So it does give them really good feedback, and it helps a lot of problem solving. When something doesn't go right, which is so much the case in technology, they have to figure out what went wrong and figure out how to solve it. So it's great from a problem solving standpoint. And you can scale them over time. So you can start off with, a school may get a grant and they're buying, say, 1 or 2 aircraft. And then a couple of years later, they want to expand that and add a couple more. Maybe they want to change from a more basic flight controller to one that's more advanced. And so your program can scale and grow based on what you're trying to accomplish or as your students kind of advance. Most kits, these kits are all rebuildable. So you can put them all together, have the students build them, take them apart at the end of the semester, at the end of the year, and then the next year or next semester, another group of students can come back in and put them all back together again. And again, as I mentioned, they're upgradable, and they have, gives you a really good opportunity to grow your program. And so as the teachers get a better understanding of the drones, then they may want to step up to more advanced flight controllers or additional options for the aircraft. So these are aircraft that are more outdoor ready to fly. These are ones that are more representative of what they would see if they were leaving high school and going to get a job flying a drone. So these are different scales. A lot of the kind of work that's done with these is there is aerial photography, there's aerial mapping and surveying, there's inspections, There's public safety work. There's a lot of different options. There's also motion picture filming. That is a pretty specific type of flying. But these are examples of aircraft already built, ready to fly. They are good, reliable systems. They are reasonably complex in that there's a fair amount of flight planning, and there's software use that is typically tablet-based, where they're planning their flights and conducting their flights. So, but they're tested, reliable systems, and they're well suited for most applications. And this is kind of a fun one. So not all drones are multi-copters. So what we saw earlier were all multi-copters. So, so here we have on the upper left, it's a fixed wing aircraft. The one next to it is affectionately referred to as the flying trash can. It's actually a drone that's been around since the 2000s. It is made by Honeywell. And essentially it's got a 2-cylinder reciprocal engine in it and a big old fan. And then down below are ducts. So it's a ducted fan system. On the far right is a remote control drone helicopter. That's actually made by Yamaha. They have been using those for crop dusting operations in Japan since the 1990s. So they're not new. On the bottom left is a hybrid. So that aircraft has 4 motors to take it up vertically, so it can do vertical takeoff and landing. Once it gets up in the air, that rear propeller will spin up and it'll start go into forward flight. And then the 4 propellers that took it vertically will shut off. The advantage of that is you can take off and land in a small space, but fixed wings take significantly less power and typically have a lot longer flight time. So it's a way to be able to get kind of both of those options. And then there's weird stuff. So that one kind of in the center right, I think it's like a flying saucer or somebody tried to create. So not really a tool, but is kind of fun. And I've seen all kinds of weird things over time. So I've seen students, I've seen groups of kids make quadcopters out of toolboxes, out of all kinds of different things. Bicycle wheels. If you can put 4 motors, a flight controller, and a battery on it, you could pretty much make it into a drone within reason. So anyway, just kind of fun stuff, and it's a way for them to be creative. Some schools get interested and they just want the hardware. They want the motors, the flight controllers, the ESCs, the GPS, they want all those pieces, and the students are all going to build their own frames. And that's a great way to do it. It gives them opportunities to really come up with their own ideas and test them out and see if they can build something that can fly. So, and that's really kind of it. What's important when we get into this, whether you're talking about indoor flying or outdoor flying, is really creating a safe way to do it so the kids understand and kind of have fun with this new technology, do it in a safe way, and a way that the teachers are comfortable with, so they can expand and add innovative technology into their classrooms. So that is all I have for this session. So the longer session we'll do this afternoon, we'll go into a little more depth about all of these, and I'm open for questions.
So we only have about 2 minutes before we need to go off to Ghana and do the zipline tour. So maybe we'll just go do the zipline tour. But if you guys could do this poll, I'd appreciate it, just to see how well you were listening. So you have to go down. There's 4 questions, just like the